Welcome and thank you for attending this talk about container security. I can see that security is on everyone's #1 item in the list. So, out of people here, who is running containers in their environment, whether it's dev or production? Yes, that's great. So here at Salesforce, we do run containers in various environments, ranging from dev, QA, and prod. And I would like to talk about our experience from a DevOps security standpoint, from an investigative standpoint, and securing the environment standpoint. So the agenda, well, we'll be talking about threats, the pipeline, monitoring, how to secure it, and how to keep an eye on these things if they eventually become insecure. And if we have some time, maybe a demo. So, containers. If you know about containers, they're pretty much processes running within the, most of the time, Linux OS kernel. Nowadays, it's in Mac and Windows as well. But they face the same challenges that regular processes face. So, a container is a wrapper around an existing app, and it is an isolation environment that attackers will strive to break out of. So these will be within the container. Once they break out of the container, they will try to go to other containers to have access to other sources, and of course spread even further to maybe leverage your platform to do denial of service attacks to others or attack you yourself. And also the other risk comes from insider threats. For example, can an employee or some insider manipulate your images, meaning your source of truth for containers as they run in memory, and result in malicious types of activities. Also, the other threat that can come, which is sometimes unintended or overlooked, is unpatched operating systems and, let's say, third-party libraries that you're using within your applications. So let's talk about what we can do about these things. Pipeline security composes of, generally speaking, securing your platform, your OS, even your hardware, if you're doing TPM, TXT type security. Access controls, whether you provide access to your Docker engine to all your users, or do you provide access to your host to all of your users, or whether you segregate dev from prod. Content security, whether this is the image itself or the application that runs within the container. And then, of course, to keep an eye on these things that are running, you need to have monitoring and, of course, plan for the response in case of a eventual attack and a resulting compromise. So, what does a general pipeline look like within our environment? So, the cycle starts with the base operating system image, which is consumed by the developers, and the developers build their app on this base image, produce their own image for further testing. Release engineering takes this up, pushes it into the registries for continuous integration to pick up. Of course, these are the underlying processes involve registry signing of these images, and the notary, which is the source of trust or source of truth for all these processes, where devs, prod, release engineering make sure that these images are coming from trusted sources. So once the release engineering gives a thumbs up, they get pushed to prod registry, and then the prod systems pull these images and launch the containers in production. All these steps are being monitored, whether it's log, runtime execution, and authentication schemes. Also, you should be monitoring all the activities that are taking place from a push-pull of the image standpoint as well. So, generally speaking, access control should be done over authenticated means. In this case, we're using LDAP over SSL. So, making sure that everyone is who they are and make sure they are doing their transactions over secure channels becomes important, because if it's not a secure channel, eventually somebody will be able to inject some traffic through a man-in-the-middle attack and compromise, for example, your image that you think or you assume are good state. You would assume that images are signed, where environments that images are not signed and are blindly pulled and pushed, this becomes important. So, for example, in prod environments where real users are not involved, you would like to make sure mutual TLS authentication is taking place between the registry and the host systems that are pulling these images. Talking about trusted registry, Docker has a trusted registry hosted on-premise, preferably, because you don't want your images going to the public in case you have intellectual property that you don't want to share with various organizations. And also, you would like to have authenticated transactions that you control that are hooked into your own authentication backend. What you would also like to have is separate the dev and prod registries. So in our case, we want to make sure that there are checks and balances in place where devs are not directly able to push artifacts to production without being reviewed or tested. Also, all these validation that we're talking about are integrated into the continuous integration cycle, where devs, when they pull the images, they are not aware of the verification, but if it's not verified, they will get blocked or alerted about the invalid image. Or if things are going to production, they won't be able to get pulled or executed if they are not properly validated. Docker Notary, as we mentioned, is a source of truth, meaning it keeps track of signatures, whether things are being signed properly, who owns what, and if they should be within the cycle or the pipeline. And of course, the notary provides the transparent verification of all these images, what we're talking about. To give a full picture of what's going on, the devs are able to authenticate and pull their images, build their apps on it, test their apps on it, push it to Releng. Releng tests this, further signs it, pushes it over to Docker registry in our case. Also, the notary master is informed about the signatures and what's valid. And then once everything's in place, production can pull it over secure channels, and then you have, hopefully, a secure pipeline from a transport perspective. Let's talk about hardening of it. What does hardening mean? Meaning, make your platform as secure as possible through the means where provided to you without even thinking about how this thing launches. So first things first, of course, you want to make sure the hosts that you're running on are secure. What's the basic way of doing it? Obviously, patching it, making sure you're using the most up-to-date version of your OS. Also, what people overlook is minimizing the amount of components within the host system as well. Not just the containers or images associated, but the host as well should only have the minimal amount of components for running and executing Dockers or containers. So you also would like to install additional protections for preventing memory manipulation in case of a compromise of a container. And in Linux systems, this could be done by GR security or packs for the kernel. So you could minimize the, let's say, the executable ranges within your memory and prevent read-write or execution for unauthorized locations. Also, you would like to monitor your executables or binaries to see if there's an outsider manipulating them, backdooring them, and potentially gaining access to credentials that they shouldn't be getting to. So one of the concerns, obviously, is nobody wants their Docker engine or Docker daemon binary to be manipulated with in case further compromise is desired by the attackers. So obviously, you would like to leverage Linux isolation capabilities that Docker provides out of the box. So talking about the containers. Containers are the places where you can do the most tweaking for securing the environment that you're running. And first things, obviously, is making sure your images or containers have the most up-to-date base OS, most up-to-date libraries that the developers use. Obviously, it's a difficult task, right? Most applications, well, let me not say most, but some applications run with out-of-date Java libraries or Java itself because of various concerns. So you have to do the best effort to make sure you're running the latest and patched applications. If you're not able to do so, you could easily get third-party products to make sure, for example, your JVM is running what it's supposed to run. You also would like to leverage user namespaces to limit what your users can do or your containers run under. So containers should run as low as privileged as they can. No root containers, obviously, because the root container can do a lot of things. So you want to limit the containers' privileges to prevent further resource access. One of the newest things that Docker released was the authorization plugin besides their authentication framework. So Docker provides TLS-based authentication, so you can create your own certificates and force people to authenticate to the Docker daemon for doing anything. On top of that, they also provide the Docker plugin for authorization, where you can integrate with finer controls based on your existing, for example, Active Directory groups and whatsoever. You could even integrate it with other means. Pretty much, the authorization plugin provides you with a clear slate to start with. And we've leveraged this capability in our environments, and it's provided us with finer controls as to who can create, run, and manipulate containers, or even restart the Docker engine itself. So that's one aspect of access control. The other aspect of access control is what the container can do, right? So containers by nature share the kernel with the host. And what you want to do is know what this container does and not just trust your developers or release engineers to put the things together properly. And maybe there's someone in the past or in the pipeline that injects malicious code or extend the capabilities of the containers, or just some last-minute patch can, for some reason, that hasn't gone through proper security testing, accesses your host resources. So leveraging the existing capabilities called secure computing mode, what this does is provides you the means to generate a profile for the container, meaning what calls it can make within the host, meaning can I touch even the kernel? Or if I can touch the kernel, can I dismount something? Or can I mount other resources on the system? So what you can do is, before pushing your container to production, you can run it within a sandbox-like environment using seccomp, run your unit tests on it, and then generate a profile based on what a baseline behavior looks like. So if you can baseline your container's behavior, you know what it's capable of doing in production. So even if it's compromised, whoever is in it has limited access to resources, or it can only do a known set of actions. And it becomes important because you don't know what the dev has put in there. You are only capable of testing what's been defined in the unit test. You run some security scans. Sure, you've detected vulnerabilities, but during execution, there are certain things certain advanced attack techniques that chain exploits together that you definitely will miss during testing. Nowadays, modern exploits involve chain attacks, and you want to minimize your attack surface as much as you can by limiting what the processes or the containers can access. Further tweaks based on what I've been talking about is the limiting privilege execution, also limiting access to Docker, the Docker Linux group, since whoever has access or is a member of the Docker Linux group can do whatever they want. unless you're using the Docker authorization plugin, which provides you with more granular controls. You want to also limit as much as you can the resources that a container has access on your host. You don't really want to share the file system, for example, or other resources. Also, if you want to even further lock down your container, you can make it immutable by providing it the read-only flag. And again, needless to say, but always strip down your container base image and your libraries or apps as much as you can to minimize the attack surface. Because eventually an attacker will gain access, and you want to make it as hard as possible for them to gain further foothold in your environment and give more time to your, let's say, security people to detect a possible or compromise that has happened and take their necessary action. Docker provides you with capabilities to run baseline checks. Docker Bench for Security can give you an idea about how secure you are running. Even if you've done this check, you probably need to do more. But this gives you a good idea about how secure you are out of the box. Vulnerability management. A lot of people skip this step. They think just doing a scan and patching is sufficient, but you would need to have a proper vulnerability management plan in place. And also, you want to make sure that you're doing vulnerability detection at various steps. First off, even before execution, a lot of people think, oh, vulnerability scan happens on the network. Not so. You have to do vulnerability scans on the base image, on the OS components, on your applications, even if your auto or manual source code audits have happened. Because although you've been given the thumbs up to run it on your platform, talking from security or sysadmin perspective, you also want to make sure that anything that happens in between is discovered. Whether it's an injected library or a tampered executable, you would like to, or some last-moment patch by a dev, most probably that will be the case, that might downgrade the libraries or downgrade the version they're running and expose you more. You would like to detect these things before the container launches. Once the container launches, you want to make sure that with your network scans that what's being exposed is what's expected. So no unexpected ports on the network, right? Although you hard code what ports are being exposed, things might pop up. You never know. So after you've made sure everything's patched, there's a window of opportunity for the hacker there as to when does the new packaged image get pushed to production. A lot of people are not pure continuous integration platforms, or a lot of companies don't follow that. They have release cycles. And these release cycles can be monthly, daily, who knows, quarterly. So that release cycle gives the attacker an opportunity to compromise the platform. So what you want to do is have a vulnerability management plan in place that you can properly grade your vulnerabilities, assign SLAs to them based on the criticality, and make sure everything's followed accordingly so you don't give the attacker a chance to compromise your platform. Also, well, relaunching the containers in this case is hopefully you're running a distributed system. Should not really be problematic because you would have multiple containers in the environment. That probably will provide you the necessary cover while containers relaunch. Monitoring. Of course, you would need to know what's going on in your environment, right? Especially on the network. If an attacker is on your environment, it will come through your network, most probably, and go out through your network in case of data exfiltration. So what you want to do is monitor your networks both on the containers, inter-container communications, host-to-container communications, and containers to the public internet. Also, you want to lock down your network environments based on security zones. You don't want your dev environment commingled with your prod environment. You don't want your dev environments that handle production data commingle with your dev environments that have just garbage data because of various reasons. So just generally speaking, a diagram of how things are laid out. We are able to monitor both the traffic that is going out of the host through taps and spans and various locations on the network. Also monitor the intercontainer traffic by piping the traffic from the host over to our monitoring resources, which are generating IDS alerts, net flows, and other types of alerts, and pipe it into our log monitoring solution. And then we are able to generate dashboarding alerts and other artifacts that make it easy for our security guys to detect and respond. So we've already talked about what we are doing, but the next step is the hosts themselves. You've covered the network. You can see what's going on. What's going on in your hosts? So the best way to see things are, or the easiest way to see things are forwarding the logs, right? You want to have as much as visibility into your logs as you can, your authentication logs, your system logs, your, let's say, audit D logs, which become important, especially from a syscall monitoring perspective. If you've enabled audit D to monitor your syscalls, you can and if you're not using profiles, or if you're using profiles, you're easily able to detect any unusual calls to the kernel, for example, or other system resources from containers. And on your SIM or monitoring platform, you can tweak or set it up to alert you if there are unusual calls going out. On the container and application side, what you would also want to do the same thing. A lot of people think just authentication logs or host logs are sufficient, but they overlook application logs. And when something gets compromised, you won't see the compromise that has happened initially on your host logs. It will be in the application logs if you've set it up properly to log stack traces, of course, without saving any critical data or sensitive data. You also want to make sure these app logs are forwarded to your SIM and properly correlated with various host artifacts so you can minimize your false positives. False positives become a real concern, especially when you're doing log monitoring. So you want to correlate all these different sources as much as you can to minimize false positives and make it easy for your security people to act on things and not just get overwhelmed by all these alerts popping up. Correlation with different resources means correlating with also the network resources, net flows, IDS, and hopefully you have the resources to raw network packet capture. This also becomes important when you want to do a root cause analysis. You want to know how the attacker was able to get to your system and what they executed on it, so you're able to patch that system for that specific attack or limit your attack surface. Also, it's important from an exfiltration standpoint if they're beaconing back to the command and control system or if they're sending back your customer data. You want to know how much data you've exposed because you will have to do some damage control eventually. So file system integrity, we've talked about it. We want to also monitor the memory. Memory becomes really important because when things are executing, they will be naked in memory. There's no hiding. And Docker and container are processes, and monitoring their process space becomes really important because if something gets manipulated, changed, or some shellcode gets loaded to the memory, you want to know if and when that happens. So let's talk about digital forensics. Digital forensics usually is a part of an incident response plan, and incident response plan and policies are also usually overlooked, and it's only concerned most of the time when you're dealing with, for example, regulatory agencies, PCI, FedRAMP, or those kind of things, because they make sure you do have those plans and policies. But most startups don't consider incident response plans because they're not, pushed into doing it. But it's an important part that people need to consider, because it's not a matter of, I keep saying always, it's an old adage, but it's not a matter of if you'll be compromised, it's a matter of when, and reputation means a lot nowadays, especially for startups who are fragile and need funding. So having a plan in place provides you a structure with how you will deal with compromises, their timing, who needs to address what are you doing in case of a compromise, and how you wrap up the compromise process. So components of a digital forensics involves disk forensics, network forensics, which we've talked about some bit, and memory forensics. And disk forensics is pretty traditional. Nobody does nowadays full disk imaging and analysis, but mainly it's focused on specific important artifacts such as logs, in case of Windows registry, and other types of artifacts such as binaries. Tools you would generally use are pretty standard nowadays. Open source free tools can be as useful as paid tools, and SleuthKit, for example, is a great tool to do file system analysis. Next, once you have your artifacts in place, what you would like to do is build a super timeline, and the super timeline will give you a global view of all the things that have taken place, organized by start time till the end time you've generated your artifacts. Memory forensics. Memory forensics is used to be R&D topic, but nowadays a lot of organizations are doing it, integrated into their continuous monitoring systems, and are also leveraging it heavily in their incident response. The question is, and it lets you query that memory to get in-depth information ranging from in-depth kernel structures. If you're familiar with GDB or WinDebug or things of that sort, it provides a similar interface into your both kernel and user space processes and objects. Sampling can be done via LeanPMAM, which is a part of the GUR framework. It's created by Google. And Lime also is another open source solution that you can dump memory with. What can you do with the volatility framework, right? So I'll be covering the basics. This is an important one because you want to see your execution ownership, right? What has the container or the Docker daemon launched, or who owns what, right? You want to know, you want to see the tree and make sure things that are running under the Docker daemon are the things that you're running. In case there's a process injection attack, right, it can happen. An attacker can manipulate your kernel process list to add kernels to it, or even hide them. If you are looking at the memory, hiding is not possible because you can do a scan of the memory and detect all the process objects. Another thing is we've talked about loading libraries. So libraries can be side-loaded into processes, and this increases the capabilities of attackers that have a limited space to begin with. To detect this, you can run the process maps plugin in Volatility and see if there are any unexpected libraries in place, like libgcc or other libraries that increase the capabilities of an attacker. The other and the final capability I'll be talking about is process integrity, which is really important from the aspect that if your Docker daemon gets modified by an attacker, or if your container running in memory gets modified by an attacker, current capabilities or products out there do not provide this. You would actually have to run something such as Volatility Framework, look into your memory, see if there's a manipulation of the memory compared to your base image, for example, your Docker daemon gold image, and comparing to what's running in memory, and see if there isn't a difference between those two. And once you detect it, act on it. So the example here shows a ELF executable, which is a Linux executable. The header gets modified from 7F to 91. The plugin process compare that's run within the Volatility Framework, once it's executed, can detect this difference and highlight it for you. So pretty much you are able to monitor your Docker daemon and your containers for any process integrity compromise, even if it's not in real time, but in rather frequent steps. So summary, we want to make sure that we are securing the full container pipeline, starting from the dev till production, including network and other all infrastructure components that you are basing your container pipeline on. You want to make sure everything's isolated, hardened, you're following best practices at least, and you're doing your vulnerability scans, whether it's just disk artifacts or network endpoints exposed. You want to make sure the content you're running is what you are really thinking you're running, whether you need to sign things and sign your images, sign your code even. I didn't talk about that, but code signing becomes an important part of this software supply chain, which is encapsulated within the whole container concept. Leveraging notary becomes really important as a source of truth. Access controls also, you want to know who can have access to what they can execute from an authorization standpoint, and how they can interact with your container engine itself. Also, you want to keep an eye on everything. You want to have an incident response plan in place, a vulnerability management plan in place, and be ready to act on these things and test them frequently. Testing is really important because you want to be prepared in the case of an attack. You want to make sure that your people have the capability to act on these things in a timely manner. Most of the time, people just create a document and have no idea what's in it because people have left or they're no longer relevant. When the time comes, they'll be just staring at the document and wondering what they'll be doing next because it's no longer applicable to the situation. You also want to have a staff and the tooling capable of doing digital forensics because you will be getting the question of why did this happen, right? How can we prevent this from happening again? And why aren't we doing a better job? To be answering all these questions, you need to have full visibility of your environment. And to do that, you need to be prepared. So, come to the end. Thank you very much for attending and hopefully being more aware of security in general, because all these concepts that I've talked about apply to all levels of infrastructure. It's not just container security, but it's all security starting from IT or prod or dev or classic infrastructures. If you would like to view the references, the slides will be available. I have included them all in here for further research. And, well, again, thank you very much. And if you have any questions, please feel free to come up to the microphone, and I'll be more than happy to answer here or after.
So the questions may not be related to security, but
sure.
In general, how widely container used in Salesforce, within Salesforce? And second question is, if I understand correctly, right, the force.conf is still one big monolithic code base?
So yes.
Does that mean you run that in one container?
So adoption of containers is not 100% within Salesforce. So core products still run within the classic environments. Acquisitions, or let's say services that are not within the core that provide API type access, those are running mostly on containers. So hopefully I'm able to answer it. I can't.
The second question regarding the monolithic is still big one piece of code, right? The force.conf. They are not running container.
That's correct. So the core components are still running in the classic environment, as I mentioned.
So are there any open source libraries by Salesforce on Docker which are released for org deployments and org testing?
So as I mentioned, the core products that are offered by Salesforce are not utilizing or leveraging containers yet. There are other services internal within Salesforce that the core leverages that run on containers. So end users are not able to currently leverage containers directly from the Salesforce, let's say, exposed feature set.
Okay, if you had to advise something that you can use for Salesforce, like in continuous deployment or something, what would be one use case as of now?
So within Salesforce,
Yeah.
you're asking. So what I've been talking about is usually is about how we leverage containers within our environment. We are not exposing that yet to end users, such as yourself, to be able to spin up your own environments or your own sandboxes. So that is not being offered at the moment. Yeah. Thank you.
So Heroku seems to use a different kind of paradigm with the dynos. How does this compare to from using Docker versus the Heroku dyno model?
So Heroku has a whole different paradigm of operations. They run on AWS. They have a different view on things. So as I mentioned, containerization is not 100%, and everyone right now is following their own interpretation or are in the different levels of containerization, whether they're only leveraging it within their DevOps or development cycle, or whether they're doing the whole development to prod cycle. So I don't know what parts you would like to compare of Heroku versus what I've just talked about, but these components here are more closer to the Salesforce core components. Heroku likes to live in their own world.
I was just wondering if there was a broad Salesforce direction. Either Heroku was going to use, Docker as their new platform, or they were going to...
Yeah, you would have to ask the Heroku guys.
Okay. One more.
Sure.
What base Linux OS distro do you generally build on your Docker containers?
Yeah, I'm not sure if I can disclose that information, but it's a Linux flavor. Well, that seems to be all the questions. Thank you very much for attending.